Okay. So thank you for the opportunity to talk to folks. And I'm going to reveal immediately, this is clickbait. So I'm calling this cutting edge reproducibility, and that gets people excited and all that. What I'm going to describe is really an old hat for many other sciences, especially in the data science part. Personally, exposed to some of that on a regular basis because my son is a student in computer science, and what he describes what they do in the very first semester is very different from what I would like graduate students to do in the very first semester. And
Lars, can I just interrupt really quickly?
Yep.
So we can see your entire screen, including our own Zoom video.
Oh, sorry about that.
Okay, thank you so much.
And so I'm calling this cutting edge reproducibility in economics, the focus here being that the tools I'm going to present are not really cutting edge, but they are in economics. So one of the things that I hope to address with what I'm going to describe here are problems with computational reproducibility that I face as data editor on a regular basis, but that are not uncommon to many other folks out there who sort of share among a work group and things like that. So those involve changes to the software, right? What happens when Stata upgrades? What happens when MATLAB upgrades? Changes to packages, whether they be in R or Julia or Stata, things break because they are not subject to the same kind of development expenses, et cetera, that the big corporations that maintain some of the other software or the scrutiny that some of the open source core libraries get. Those packages are extremely useful, but they're not always done by professional software programmers, and so things break. Big projects have many steps. There can be inconsistencies that build up over time across these steps. There can be inconsistencies as members of the team do part A, part B, etc., and they don't necessarily mesh with each other. There's how do you adapt to confidential or big data? Can I bring part of the analysis there? Can I illustrate what it is that I did on the confidential data in a way that sort of lets people say, yeah, that seems reasonable, right? We encounter all of these things all the time, okay? The solutions that are seldomly used, and this is only going to be a partial solution for some of these problems, are things such as regularly automated recomputations and the packaging of the entire artifacts that are part of the whole replication package as one piece, okay? What I'm gonna try to convey is that while this is a hurdle in setting up initially, it actually carries benefits over the course of a project because you can, the whole point is that you can very easily decide early on where things are going to be checked, and you can detect where things break much, much earlier. So you're not going to have surprises that we have also seen authors come back to and say, oh my God, I didn't know that that file was the wrong file. It completely changes the results. I'm responsible for detecting that, but the author tends to have fixed that. And I sincerely hope that people sleep more soundly just before submission of the article than has been the case in some of those things. Okay. So some of you who are more aware of these things are going to come around and say, yeah, but you know, there's all these fancy versioning tools that open source has, right? R has Renv, has PackRat, has various version package repositories. Julia has various ways of doing these things. Yes, that's true, if you actually use them, because most economists actually don't when we see that. But there is a hidden cost to some of these. This is only a partial solution, right? For one, for instance, take Julia. All of the Julia packages are hosted on GitHub, and they can just as easily disappear from GitHub because that's in the domain of the owner of the code and not somebody else, okay? Doesn't happen very often, but it is something to worry about. They have excellent version pinning qualities, right? But what if you have something that doesn't use such a package manager or things like that, that doesn't have robust versioning? And here I'm looking primarily at Stata and MATLAB, and as it turns out, that's what economists use, right? But even if you have pinning of certain packages, that's incomplete, because even if I pin my package, what's the version of R that I use to run this? And what's the version of the underlying libraries that are within the environment in which I computed this, right? So most economists, most social scientists, many others as well, use as simple as install packages, right? Or even worse, well, RStudio prompts you to install a package, just click on it and do it, right? You can pin versions. So there's a better way of doing that. That's mostly not used, but you can also even constrain it to invoke certain versions depending on the version of R that you're running. Right? And I can go out and grab earlier versions of R because almost all of them are out there, but it's actually not trivial to have multiple versions of R on your computer, right? And I can tell you RStudio doesn't like it at all if you have multiple versions, so that already is a problem there. Okay, so what happens when you have proprietary software? Nothing of what I'm going to describe to you actually changes if you use open source or proprietary software, with one caveat, right? The whole point of proprietary software is that there's a license attached to it, and there is such a thing as license rot. It also occurs over long periods of time, but just try and run a 5-year-old version of MATLAB in your university lab, that might be a bit problematic. It actually works reasonably well with Stata licenses, as it turns out. Okay, so everything that I'm going to show here works with proprietary code as well, under certain caveats. I'm going to show you the easy to use Stata version because I've invested the most in that, because that's where, as data editor, I get the most payoff. But this works with MATLAB. We've done it with MATLAB. It works with Intel compilers. This is like super sweet for Intel compilers. It works with Ruby optimizers. All of those things have some sort of license attached to it that is a bit of a hassle, that have some install component attached to it, and those things matter when you try to reproduce research. Okay, now what I'm going to do is call containers, and we've all talked about certain best practices. Containers are a way to actually force you to adopt some of those best practices, right? We are going to, by necessity, have to do push button replication, because if we're going to run through things on a repeated basis, that's going to just have to be part of the way to do this. And so master scripts are necessary. There is no manual copying of results from A to B or something like that. There's no manual install of packages. There's no click on RStudio to install things. And you have to sort of already adopt the idea of platform neutral paths, which are the Unix path. Sorry for all the Windows users who are not used to that. As it turns out, that's one of those things that is really badly conveyed even by the providers of the software. Every single statistical software under the sun that I'm aware of accepts forward slashes. There is no need ever to do any of the windows. If you want to take one thing away from this talk, do that, right? That'll make life so much easier for others. Okay, so I'm going to walk you very quickly through an example with R, because that's what most people see, where I'm going to illustrate the points that we're trying to make, where the difficulty might lie in doing some of these things and solutions to that. And I'm going to then switch to demonstrating the same thing with Stata. In the interest of time, I'm going to make this relatively quick, but all of the information, including the examples, runnable for anybody who, in the case of Stata, has a Stata license, but for anybody else with the R, are in the links of this presentation. So there's two elements to this example that we're going to do. It is potentially big data. I'm going to illustrate it with a sample of it, but it takes a long time to run just because it's big data. And in the R example, I'm going to use something which should be private, an API key, right? Which is, if you follow all the instructions, stored in a file on your computer. And so if you look at all the normal instructions, you're going to wonder, well, how can I ever get this to work in an automated fashion by anybody out there? Okay, and I'm going to show you how to do this. So the goal is to make it robust, repeatable, push button, and in the cloud. Okay. So the example is an adaptation of an example for the tidy census package. We're going to use Census Bureau data from the American Community Survey. If you wanted to download the entire data set, it's 100 gigabytes, and that's what lots of economists will do, and then pick out 3 variables from that. But we're going to use the API to slice the data. Okay. The typical way this is explained is get yourself an API key from the census. It's free, brief sign up, you get the key, etc., but it's tied to you, right? So you don't want to put this out there in the open because somebody might abuse it and you get the blame. okay? And here on the screen are the instructions on how you're supposed to store this, right? Put this in a file that's on your computer that somehow works there, etc. Okay. And then we can sort of read this in and install it. And we need this key to be present when we run our quick query here. Okay. So my illustration here is going to be, I'm going to pick a few variables that exist for every block in the United States from the 2010 census. And here's the call in the tidy census package. Wonderful package, works marvelously well. So I'm going to pick out one county and get all the blocks for that county and the variables for that. The variable is called P013001. I'm not going to explain it here. You can find out how you can find these variables within the API, etc. Right? So this is literally a log output from this, because this entire thing is a reproducible document. And so for this one county, when I ran this, it took less than a second to run. Okay. So that's one county. There are 3,200 counties out there, right? That could start to be some. And I picked a county that doesn't have that many blocks. There are different counties out there. Counties have varying numbers of blocks. Blocks are invariant somewhat to size, but counties are not. Okay, so let's just pick the first 30 counties to get an estimate of how much this might be if we sort of do something more. So we're going to pick a county. We're going to run through this again. We're going to grab all of these things and concatenate them together. Okay, that takes 18 seconds for 30 counties. So if I sort of scale all that thing up, my estimate is that on my particular system that this is run on, this will take about 33 minutes. Okay, I'm going to get back to where that 33 minutes actually come from, because that's not the time on my laptop. Okay, what are problems that can occur here? Why is this an illustration of what I'm trying to convey? The API could break, right? The API could, the package could break, my code could break. And so I kind of want to keep this in mind when I sort of run through this. Of course, the data in this case is very unlikely to change, because when the census releases the decennial census, that doesn't change, but that's not true for other things, right? Think of querying a bank API for credit card records, or querying something that is more dynamic, Twitter, say, okay? So how do we detect problems early? This is a concept from computer science or software engineering, is continuous integration. Just every time you make a change through it, you check the robustness of this thing as you go out. Right? And the reason, say, that your word works relatively well without too many bugs is because they do this constantly in software engineering all the time, right? And so it's the process of automating this kind of build process. So the key thing why I'm bringing continuous integration is because that's the term you'll see explained when you sort of look around the internet and find examples of how to do this, right? So every time we make a change to the code, the entire code sequence is run through, right? But the code runs 33 minutes. You really want to do that manually every time you want to run through the code. And so relax, we're going to set this up as a cloud computing exercise, right? So there's 4 components we're going to need for this. GitHub, a thing called GitHub Actions, an API key that has to be kept secret, and something called a Docker container. Okay, so what are all these things? I hope that this group doesn't have to be explained what GitHub is. It's one of the hosted Git repositories out there, but you can do this with GitLab, you can do this with Bitbucket, you can do this with several other things out there. There's nothing about this that is very specific to GitHub. So you can do this behind a firewall in a confidential computing environment if you have the right infrastructure. GitHub and GitLab and all those places actually sell the software so that things like the Census Bureau can actually have an internal instance of this and can do all of these things internally as well. Okay, what are GitHub Actions? Well, this is the continuous integration thing that is either built in or can be connected to these various Git repositories. Again, there's a whole slew of them out there. I've used Travis CI, I've used Bitbucket pipelines, I've used GitLab CI. They all have different configuration parameters that you have to wrap your head around, but they all work the same. Okay, GitHub Actions secret is that parameter that I need to stick into the cloud. And again, all these services have some way of sort of conveying secrets, right? And Docker, that's the container solution that we're going to talk about here. You use it every day, every time you watch Netflix or something like that, you're using Docker containers behind the scenes as they scale up, right? So I'm not going to explain too much about this. There's a whole blog post I have about that. But if you want to go out and do that, what I'm going to give you here is a synopsis for this. Okay. Also, I'm going to call it Docker. Everybody else calls it Docker, but it's not the only name of the game out there. There's Scilabs as well. There are other container setups out there. All of this also works with these other setups. So the basic principle is just for illustration. Okay. Docker in economics is extremely rare. I have not seen one single submission of Docker as the primary instrument to sort of convey reproducibility in 1,000 papers. That is too low. I'm sorry. That just is not the right state of affairs. I have seen some submissions, really, really rare, that use some of the other tools I'm going to point to. Okay. What does Docker buy you? It essentially captures all the software pieces in one package, and now it's software as a package that all of the things get stuck in, and unless you start to rebuild it, all those stay fixed for the foreseeable future. And it's transparent the way it's put together so that you can also see what are the setup steps. So it tidies up how that entire setup that in many cases you will have to run through for more complex setups, how that actually goes about. And it's not a panacea, because if your setup or if your code goes out on the internet and does funky things, then you also break reproducibility at that point. Okay. They come with a configuration set. For Docker, it's called a Docker file. Singularity has its own thing for that. And so those things are very transparent. You can link to the one that I use to create this presentation, and we can walk through that if somebody wants to. But you have to avoid things like, oh, I'm going to just update all the packages as part of the code that's going to run within that container. Okay. So as I've said, we've used this to run R, we've used this to run Fortran, we've used this to run Gurobi with Intel, we've used this in various guises to do so. It is very flexible, and you can run Stata through it as well. Okay, so walking you very quickly through what this might look like for R, this is what a Docker file looks like. You have a setup script that installs all the packages in R, and you leverage the officially maintained R Docker image from a group called Rocker that is tightly tied into the R fundamental developer group community. Okay, and that's it. This is exactly the specification. Okay, it can get a bit more complex, but I can now build this. And for this particular presentation, I have built this, so you can see exactly the configuration I used to run these slides, including running the census example. And then I can make it available to others to use by pushing it out there the same way that you would think about, say, a Git push. Okay, so if somebody wants to go out and use this, then all they need to do is pull down this version with Docker. Okay, you would do something like this. Go to the code that you've checked out from me, and then run this Docker command line. Or we can let the cloud do it. Okay, so what do we need extra to do that? Well, going back to those elements, we need GitHub to store the code. We need GitHub Actions to run the code. We need the API to capture that census API key. And we need a Docker container to run all of this. Okay, so this is what GitHub Actions look like. It's a set of steps that are in a plain text format. Again, like I said, there's a learning curve to doing this, but you can take my example as a way to bootstrap yourself into this. You store the census API key in a secret way on GitHub. If you want to learn how, here's the key on how to learn that. And we're going to leverage this image that I just created in the cloud as well. Okay, so I can run this locally, I can run it in the cloud. And then every time I push a change, I can go and have a look at that. So for this particular presentation, this is the stuff that I ran last night. Okay. This is the even more complex Docker command line rule that I don't have to specify, because that's the magic of using these recipes out there for doing that, right? And you're going to groan and say, "Can you? Is that really supposed to be so hard? Can you make that easier?" Absolutely. So how do we make this easier? Now we're going to lose something if we make it easier, but we're still going to gain a lot in terms of reproducibility. There's a couple of websites, again, they're linked here, that use Docker in the background. And because they use Docker, you can typically run things both on the platform, and if you're a masochist like myself, you can also pull it down and run it locally, right? So CodeOcean, Wholetail, Binder, and there's several others. There's a nice overview in this Concol et al. Piece where you can see many of these resources that are out there that leverage these kinds of things. And they do it in a very transparent way because you can download all the components again. And if you don't want to rely on them for the future, which is always good if you're thinking about future reproducibility, all of what they do can be replicated locally. Sometimes with a bit more setup, but typically not a lot more. Okay. What you lose is continuous integration, right? And so while CodeOcean, for instance, has a button that says reproducible run, which will run through this, it's a manual button. You have to press it instead of sort of having it run automatically every time you make a change, right? So it's reproducible, but it's not continuous integration. Okay. But for all I care, for journal submissions, we can stop here and that's it, right? Because if you run something through CodeOcean, we can export it back. I can run it offline. I can run it through it. I can just believe that it was reproducible because it is reproducible by design. Okay. I have run this particular image that was used to create my presentation, including the census analysis on my Linux workstation, on my Mac workbook, and I've run it in the cloud as well. As it turns out, those 33 minutes, for instance, come from running it in the cloud. On my MacBook, it actually takes 50 minutes, or it would take 50 minutes to run. And I haven't run it recently on my Linux workstation, where it probably would be quite fast as well. Okay, so in the last remaining minutes that I have, I promised you Stata. So Stata you'll get, but not exactly the Stata that you're used to. Because of course, you're going to have to think about Stata in the command line here. There is no GUI for you to interact with. That's the whole point, is that there is no interaction going on. Fundamentally, Stata makes it not too hard because you're always typing things into the command prompt at the bottom of your screen. What you do lose are things like you no longer are able to manually save and modify that figure. And there's no data browsing or manual edits of things and no manual things. But you know, for reproducibility, you weren't doing them anyway, right? So you're not really losing anything if you do it right. Okay, so what do we need to run this in the cloud with Stata? Same things as before. We need GitHub to store the code. We need GitHub Actions to run the code. We're going to use a container here because that avoids having to reinstall Stata from scratch every time. And our GitHub's secret here is now going to be our Stata license code, because we don't want that out in the open and everybody else to run my version of Stata, right? And it's going to be fundamentally the same, but if you want to try it out for yourself, if you have Stata code, you have a Stata license, here's the link to do so, okay? So how do these things work? Well, we have to going to handle sort of re-implementing the license, right? So there's a bit of secret code here on how to do this. This uses some transformation because I need to encapsulate an entire file as a string because that's what secrets have. I can't put the file out there, but there are other ways of doing this. But these few lines essentially do all the magic, okay? And then, again, looks complicated, really isn't, and is only one minor variation in what I showed you earlier on how to run Docker for R, is that we need to provide our license in some fashion to the Docker image. So the Docker image itself can be made public. There is no Stata license in there. It's just that when we run it, we need to make our license available within the Docker, and this is how you do that. You map a file into the inside of that, right? We need to store in exactly the same way we store the census API key. We need to store the Stata license in our GitHub Actions secret, right? And if you want to do that, well, here's a command line tool to do that as well. Works like a charm, okay? And what do we use here? Well, you don't want to build this whole thing all the time, so I've done the work for you. There is now a regularly maintained by me, by the AEA team, but most of the time that's me, an official Stata package for running Stata code as a Docker container in the cloud. Stata signed off on that when I proposed that to them. It doesn't contain a license, and there's instructions on how you can get your license into that, right? And so I crafted that Stata example. You can see how it runs through the same tools that we had before. So this is all as it ran in the cloud. And you can see the results, because that's the way I set this up, is that I don't want this to just be a, yes, it works, but I actually might want to see some of the results. Now here, I'm just popping a log file into this that sort of says, here's the log file that I ran, but all those log files are kept if you go to this. Sorry, not for this. If you want to do your own, this is the tool to do so, okay? So I'm out of time. I can make this a lot easier. CodeOcean and Wholetail also support Stata, so you can start with that. You can also use one of the GitHub action templates that should streamline a few of these setup procedures as well. Okay, and this is being actively used. Okay, so here's a few of the papers that we've recently worked with at the AA, where we've used some variant of this Docker-based method. Either we've had them use CodeOcean, or we crafted our own GitHub repo for some of these things to sort of ensure that what we're seeing is actually reproducible. And we're working with Wholetail on these things as well. Okay, this is not just at the AEA, so I want to highlight the work that Thibaut does on a regular basis. So they've been using both Docker and CodeOcean as well. So for instance, their submission to the AR, which is forthcoming, used 4 different CodeOcean capsules to illustrate parts of their entire thing. And their paper also uses confidential data. That took several months to get access to and run on. Verifying that the CodeOcean stuff worked took minutes because I could look at their verified reproducible run. Okay. And the forthcoming Econometrica by Bonhomme Lamadon and Manresa is also uses Docker both as a tool to illustrate how things work with synthetic data, but also to bring the computation into the secure Swedish environment where they ran the other environments. And within research infrastructure, the Portuguese lab uses Singularity containers as one of the tools that they're exploring. So that's at least one step forward. Okay, so to conclude, this is definitely a way to make your research more reproducible, even when software requires a license. So that's not an impediment. And anybody who does Intel Fortran, please use Docker. It's so much easier. And while this may be useful in the context of our reproducibility checks, and we intend to use this more often, it is all the tools are there for you to check this before you even submit to a journal ever, right? And it enables the aspect of continuous integration. So detecting problems early and fixing them early is certainly one very useful byproduct of that. Okay, we can go into some of the downsides, but I'm kind of out of time. So I'm going to leave you with examples in the literature. If you go to these things, forthcoming papers, my blog post with other resources in there. And that's it.
Thank you, Lars. This was very, very informative. Does anyone want to jump in with any questions at this time? I think your talk resonated with some Python users in the chat, Lars, if you want to address that. Max had a quick question earlier.
So I did gloss over that because Python has a fabulous environment and package management. But when you've had to reproduce the particular environment that a particular author used, you still need to get all those things right as well. So there are various ways to do this. This does not supersede that. You would use, for instance, some of those things within that. So you can do it. This is none of what I said is specific to R or Stata was what I was trying to convey. It's just that I'm not a Python expert.
I did have a question about Conda, and because Conda offers, I think, some of what you're using Docker for. You can save versions of specific packages, including R or Python. I think it's more for Python, but I've used it for R too. So you can basically say, here's my environment. I'm going to write the whole thing to a text file, and then someone else can load that entire environment. Have you used that, or?
We have, and we have run into problems because there are also hurdles to making that trip you up because you might pin the versions to the particular operating system that you're doing on. There's some hand-holding you need to do that. Conda upgrades its tools themselves, and so picking up something that's like 3 years old is actually not so obvious either. And so this is, I have typically wrapped Conda setups into this because as a journal editor, I see multiple Conda versions, multiple Python versions, etc., coming together. And I just isolate my own system from that by running it within a Docker instance. But that being said, that's an excellent tool to set up the environment. Docker kind of makes it easier for the next person who may not be a Conda expert or who may not do all these things as well. I think the key aspect here is you should not be using Conda or the R package managers or Julia package managers. They are excellent tools for this. But if you want to learn something that you can port across all the different environments, this is one way to think about it, right? This does not require a package manager. And yet it achieves more or less the same goals.
Lars, I see Jason has a quick question, and maybe we could wrap up in 3 to 4 minutes before we move on to the parallel sessions. Jason, go ahead with your question.
Okay, thank you. Lars, I just want to hear a bit more about how you're dealing with confidential data. How is it clear how Docker helps? You still need to take, say, it's administrative data to that agency and it's run on their machines, or how are you dealing with that?
So the Lamadon, Manresa, etc. paper did some of this. The cleanest current solution that I know of is the BPLM environment, where they allow you to run, you're creating the Docker instance inside the secure environment, and then you can extract the software, but not the code, outside by just exporting the configuration of that environment, right? So because the Docker need not contain the data, you map the data into it, you can export everything. If you are particularly security conscious, you can rebuild the Docker instance inside the secure environment and have it be vetted by the folks that do these kinds of things, right? So that doesn't get at bit-by-bit reproducibility, but it gets at very robust reproducibility because you are ensured that within the Docker container, you have all the same tools, et cetera, set up.
Okay, but you do need that willingness on the other side, on the agency with the data. Yeah, and you work with
absolutely.
Them. Okay.
And you will get pushback from that in the sense of, hey, you're bringing in this black box of things. And one of the reasons I like Docker files as the way to do this is there is no black box. You want to point it at a particular instance of Ubuntu that you've vetted to be secure because that's what you accept inside. Yeah, we can do that, right? But you, as an agency, you have to invest in that. I should say that we're talking with the Census Bureau and the French system for confidential data about these tools to see if we can make them work within those environments. Promising, but not quite there yet.
Okay, I think on that note, we could wrap the session up. Thank you again, Lars, so much for such an informative talk. And we've also posted a few resources in the chat if folks are interested in learning a little more on this topic. Now I think we have